Hello, everyone, and welcome to the first AGREMO and DJI webinar. Thank you for taking time out and being here today. My name is Neven, and I'm Marketing and Communications Manager here in AGREMO, and I will be your host for today. First, I would like to introduce today's presenters. From DJI headquarters, today with us is Wing Zhong, DJI Smart Farming Program Manager. Hello, Wing.
Hello, everyone.
And from AGREMO, Nemanja, Precision Agriculture Specialist. Hi, Nemanja.
Hi, everyone.
And Luca, Head of Sales. Hi, Luca.
Hello, everyone. Hi, Nemanja.
Hi. So the adoption of VRA has been increasingly steadily in recent years. According to a report by Markets and Markets, the global variable rate technology market was valued at $2.6 billion in 2020 and is projected to reach $4.1 billion by 2025. In order to reach those numbers, today we will cover the following topics. So, challenges and evolution of spraying in agriculture. What does VRA spraying look like in the field? How does the Mavic 3M drone fit into AGREMO's scouting solution? And how does the AGRAS drone do spot and variable spraying? We will touch as well the results of our joint case study in soybean when we did with the DJI spot treatment on voluntary corn. But before we start, I would like just to go through the housekeeping rules quickly. So all participants will be muted during the webinar. Webinar length will be around 40 minutes. So please ask a question and follow the poll feature on the right-hand side, since we will just have a few polls during the webinar. And please don't worry about making notes immediately, since we will send the sessions recording your way in the following days. Without further ado, I suggest we begin. So ladies first. Wing, welcome once again. Please, you can make a brief introduction about DJI Agriculture and share some news with us. Please, the floor is yours.
Okay, thank you, Nevena, and hello everyone again. And this is Wing from DJI Agricultural. I'm a program manager of DJI Smart Farming Project. And I'd like to introduce briefly about DJI Agricultural to you all. So since 2012, DJI has been adapting the drone technology to the field of agricultural. And in the year of 2015, we established the DJI Agricultural brand. DJI Agricultural's mission is to empower agricultural with intelligent robotics and spatial technology, along with our partners for less agricultural footprint and higher production outcome. And about the product lines in DJI Agricultural, we now have two major product lines. One is the AGRAS Spraying and Spreading drone, and the other one is the multi-spectral scouting drone. So far, there are over 130,000 agricultural drones scouting and spraying crops, pasture, forest worldwide, and over 104 million hectares have been treated with DJI agricultural drones. Besides, 10 million pilots were trained by DJI Academy to be agricultural drone pilots, professionals. On top of that, while agricultural drones now liberate human beings from heavy spraying and scouting jobs in the field, resolves the accessibility issue in hilly landscapes, and also provides a timely and affordable tool for even small-scale farmers. But modern farmers, they are looking for more. They are looking for precision spraying solutions to further cut down their cost and to improve their yield. So we decided to work with industry partners like AGREMO to develop robotics plus AI solutions for precision agricultural. So in the year of 2022, AGREMO connects its precision function to DJI AGRAS drone and empowers DJI's drones to with weed detection, health monitoring, and spot spraying and variable rate spraying function. The case study that we carry out in Iowa, United States in the year of 2022 showed a 68% of reduction in herbicide usage, which is very, very exciting. So that's why I'm very happy to co-host this webinar with AGREMO and introduce you this solution. So now let's turn to AGREMO to give us the detailed introduction of the partnership and also of the integrated solution.
Thank you, Wing, for that great introduction. Nemanja, please, you're the next one.
Thank you, Nevena. So, hello again, everyone. I will be talking about the technical parts of how the AGREMO technology works and how we enable variable spraying on the field. So first, I would briefly like to touch upon what is AGREMO as a company for all of you who are joining us the first time and are just now learning about our technologies. So we are crop monitoring software which enables detailed field analytics. We made it our mission to provide usable data to all of those who are directly or indirectly involved in agribusiness. Therefore, we are mostly known for our services in crop production, such as stand count, weed detection, stress detection, or crop health monitoring. But recently, we've also developed different products, such as a product specifically focused for R&D and field trial monitoring, especially for input producers in agriculture. And the latest developments have been in products related to crop insurers, enabling them augmentation of the business and just adding additional value and precision to their work. So how all of this works is streamlined and made very simple for the user, which just needs to have any form of drone, whether it's RGB or multispectral. For AGREMO is a hardware agnostic, therefore we can process any form of imagery and give you the results. It will just depend on what level of precision you're asking. Better sensors will, of course, provide you with more usable data. After you have mapped the field, you need to upload it to the platform. And after that, the AGREMO algorithms will start their analysis. So I would like to point out that we use vegetation indexes as parameters in the algorithm, but we are providing very easy to understand and easily interpretable results to everyone, no matter your level of expertise in precision agriculture. And we also strive to always provide very easy to read and easy to use data. Therefore, we also use parameters outside of vegetation indexes, such as crop density, crop height, texture, color, and many other things that we can gather from the image itself. And then we provide you with the report that I have mentioned just now, from which you can go on to generate maps or just make decisions in your crop farming business. So as today's topic is relating into to precision spraying and spraying itself, I would like to briefly go over the history of crop protection. So what is interesting is that crop protection has actually been a part of civilization for almost as long as civilization itself has existed. And throughout the years, the form of the protection of crops has changed. It evolved from using powdered extracts or sulfur or arsenic or plant extras such as tobacco or garlic to development of synthetic pesticides, and later on adding multiple layers and developing different approaches to crop protection, such as crop rotation and other integrated methods. But all of these technologies up until 21st century have had a flaw, and that flaw has majorly been in the impact to health, either of the people applying the technologies or the environmental impact that has been largely negative, especially in 1940s with the development of DDT pesticide. So in 2000s, we have had a huge spike with development of precision spraying, which has allowed us to control where we apply the products and how much products we are applying to, which reduced the impact on the environment, but still had largely all the same flaws that previous methods have had. And then we have the first exponential jump in the drastic improvements in health and safety methods, which is drone spraying, that uses significantly less products, not only creating a financial benefit for the farmers, but also helping them preserve the environment and also keeping them safe and healthy throughout this whole process. So now that we have mentioned the precision spraying, I would like to answer the question, should you transfer to the precision spraying methods? Is it really valuable? Is there a value generation throughout this process? So the short answer would, of course, be yes. But what is precision spraying itself? So it is a technique of applying exactly the required amounts of product to exactly the areas where the product needs to be applied. So the first direct impact would be financial. But of course, as I mentioned, there are many others. So when we look at conventional spraying versus precision, in conventional, we all know how it works. We cover the areas, let's say, fairly quickly and easily. And in some approaches, it actually can be a very cost-effective when we look at the broader picture of the entire requirements for people that we need to employ, or the logistics, or just the equipment that we need to procure for this process. So as we know, conventional sprayers without any fancy equipment are much cheaper. So, and also another thing at conventional spraying, it does not require any additional specialized equipment, or it can be applied with asking consultations and not having exaggerated amounts of expertise. So, but on the other hand, we know how much product we waste, since we spray the entire field with one flat rate. Even though the phenomena is not spread out through the entire field, we also harm other species outside of the intended one, and also have a large negative impact to the environment. And in many cases, it may not be as effective, since, let's say, if we just remove the navigation, we will have overlap, or just won't spray some parts of the field. In precision spraying, all those flaws are removed. But what are actually the cons of this approach? So first thing, which is very straightforward, we need a higher entry cost when talking about sprayers. With drones, which we are mentioning today, we have lower costs, actually, compared to conventional spraying and precision. But we still need specialized equipment. We have a higher entry cost. But this con itself is removed if we just examine the ROI, since we won't spray the entire field, and much quickly this technology will start making us money if we apply it and utilize it in a correct way. We also need to start gathering data and analyzing it in order to unlock the full potential of the technology, which all leads to one simple conclusion: we need to change our farming practices. And that is the major point of this. In order to transition to precision spraying, we need to change some of the practices that we have had so far. And this is where drones come in. So since the launch of the first drone, which was DJI AGRAS MG1 in 2015, we have seen large improvements in the drone technology in crop protection, especially today with D40 drone, which is a very powerful and capable machine. The first thing that drones unlocked in crop protection is actually detecting the phenomena that needs to be treated. Today we're focusing mostly on herbicide. Hopefully soon we will evolve this entire approach of detection to also pests and diseases. And we can also, outside of herbicide treatments, we can enable liquid fertilizer application. So drone sensors allow us to know where to apply those products and allow us to precisely apply those products in the exact areas. We have lower requirements of labor, lower time requirements, and improved health and safety conditions. And all of that allows us to make more effective and efficient crop protection strategies. So now we will focus on how AGREMO and DJI allow you to actually variably spray your field in 5 simple steps. The first requirement is to have a mapping drone, which will enable you to map your field or to create a coherent image, no matter whether it's RGB or multispectral. For weed detection, we recommend drones with sensors of 20 megapixels or better at the ground sampling distance between 1 and 2 centimeters, depending on how early in the vegetation development we are mapping our field. After we have created our map, we just upload it to AGREMO and select weed detection analysis. After some time has passed, we will receive our results labeling the exact location and the surface area of the weeds. We quickly generate the prescription map with the spraying tool, download those results where we will automatically have DJI AGRAS supported file format. We just put it on an SD card, put it in our controller, and we can go to the field and spray. And on the application itself, this process, you can see here what we are referring to when we say a coherent map of the field. And here we can clearly see the phenomena that needs to be labeled. And also here we can see the results and how our algorithms will show you where the fields are located. In the upper part of the slide, you can see the RX icon. After we click it, we get a short form to fill, selecting our rates, and the VRA map gets generated in the background, and that is the whole process. So in just a few clicks, you are completely prepared to spray your field. Thank you everyone for your attention.
And now we have the first poll question. So we will have 30 seconds for that. Thank you, Nemanja, for all those useful information. And I want to welcome all those who joined later, since the number increased. So the poll session is on the right-hand side on your screen. You can vote, submit your vote. Okay, we can go on. So, Bing, please, you can continue.
Okay, thank you, Nevena. So here, considering about the full workflow, which will involve the scouting drone part, the data analysis software, AGREMO software, and then the spraying drone part. I'm going to introduce the two recommended drone model for this solution workflow. So I've talked about the scouting drone first. For the scouting purpose, for example, detecting the weeds in the field and also for health monitoring, the drone model we are going to recommend is the Mavic 3 multispectral. It is a multispectral drone that we launched in the year 2022 in November, so not too long ago. This is actually the first drone model that integrates RGB camera and also 4 single band cameras in such a small drone platform. As I mentioned, this is a multispectral camera drone. It has 4 multispectral cameras on board, which you can see from the photo here. And those 4 bands are the green, red edge, and near infrared. So this drone is specifically designed for agricultural purpose. In addition to the single band multispectral cameras, it also has a built-in light sensor on top, a small module on top. And the purpose of that is to ensure the data consistency and accuracy captured in different time of the day. So if there's a calibration of the sunlight for you automatically. In addition to that, it also has a RGB camera with 4 3 CMOS and 20 megapixel resolution. So if you are aware of our older multispectral drone model, the Phantom 4 multispectral, the RGB camera resolution has been significantly improved from the old model to this new one. So it makes it a better fit for detections that are relying on RGB camera imageries. It's also a mechanic shutter with the fastest shutter speed of 1 to 1,000 seconds. So that improves the mapping accuracy as well. The battery duration has also been improved to 43 minutes. What does that mean is a much higher data capture efficiency. So in the foreign weed detection solution that AGREMO will introduce, for that purpose, the drone is going to fly at around 100 meters above the ground, which gives you 2 centimeter ground sampling distance. And for that purpose, the efficiency in one flight, which is around 30 to 43 minutes, it will be able to cover 50 hectares in just one flight. If you are going to use that to monitor the growth status of your field, it will give you even higher efficiency with a higher flight height, which is 100 hectare coverage in one flight at a height of around 180 meter to 200 meter above the ground. So efficiency is very important in the data capture part because we want to get field work done as soon as possible when the weather allows and the season allows. So this is a big advance of the drone model. And same as our older drone models, it still have the RTK module on board. So it ensures centimeter level positioning accuracy. The transmission distance of the drone is 15 kilometers, so we are able to do long distance mapping. It's also equipped with omnidirectional obstacle sensing, so safer if you are doing jobs in some difficult terrain with power lines, power poles, or trees around you. A very important feature, real-time terrain follow. This is a new feature on the drone model. So if you're going to do mapping, the drone will keep its relative height above the ground. It keeps the height consistent. So that improves the mapping quality and also the efficiency. The drone also supports open ecosystem. It has a cloud API to enable uploading the imagery captured to a third-party cloud. So that improves the data synchronization efficiency as well. And as the older models, it also supports mobile SDK. So for the foreign workflow and the solution, this would be the recommended model for the scouting part. And
thank you, Wink, for introducing the new drones for the agriculture industry. we have the opportunity to try the Mavic 3 multispectral, and it is very, very good drone, and congratulations on the great job. To add here on the wings presentation, I would say that the AGREMO is the last piece of puzzle that is connecting the mapping drone on the one hand and the spraying drone on the other part, by providing the analytics and files that you can upload and do the spraying. So we have the files from the mapping drone that you can upload to the AGREMO, request the AI-based analysis directly on the platform in just a few clicks. As Nemanja described, we can create a variable prescription map and send them to the spraying drones and complete the job. I just wanted to emphasize here that we are compatible with all the DJI drones. We support both RGB and multispectral maps, and we are also compatible with all the AGRAS platforms. So now with this, let's say this synergy of the two technologies, the hardware and the software, there is a complete solution for monitoring and spraying the agricultural fields. As you heard in the introduction, last year we did the testing of these two technologies, where we were doing the experiment on soybean fields, where we were detecting the voluntary corn in soybeans, and we were using the DJI drones. In this particular case, we used the Phantom 4 multispectral for the mapping. We uploaded that data to AGREMO to create this map. We run the weed detection analysis. What is here specific is that the voluntary corn is a very small object that we should detect. It is a one plant in the field, which is causing a lot of problems. So we successfully detected the voluntary corns, create prescription maps, and upload that maps to the T30. We were using T30 for the spraying. So we complete the whole job, and we collect the feedback from the farmer. The farmer was very satisfied here, and he said that the same effect was accomplished comparing to the conventional method of the ground spraying, but we used way less chemical and significantly less amount of the water. So the results of the analysis shows that around 32% of the field has the weeds. This is the whole, let's say, once we create the management zones, they were around 32% of the weeds, which means that we used 68% less chemicals, or we sprayed 68%. We didn't spray 68% of the field, sorry about it. The savings that this farmer mentioned for this particular job was $17 per acre. Just to emphasize, this was on this particular field, but in general, if you want to calculate the savings, it depends on the percentage of the weed pressure in the field, and of course the cost of the chemical that you will use. Just to talk a little bit more about the AGREMO and what our app also offer. Besides the weed detection analysis that I just mentioned, we also have our plant vigor analysis, which is the specific analysis which provides the variabilities in the plant health across the field. And this analysis is the main input to create a variable prescription map for fertilizer application, which is also can be done with the DJI spraying drones. Besides that, we have the stand count analysis, which is the AGREMO's most popular analysis, which you can use to evaluate the seed quality to decide whether to replant or not. You can use that data later to calculate your yields. And on the app, we have our vegetation index-based analysis to monitor the plant health. AGREMO supports all the field crops. So far, we analyze all the most popular crops, such as corn, soybeans, sunflower, sugarcane, rice. We also have the cases, for example, in Australia, where we were detecting the invasive species of the weeds, which are specific for that regions as well. So we are working mostly with the field crops, but we can also provide the analytics for the vegetables. AGREMO is also, just to mention, the license-based application where you can process the unlimited number of the maps and the analysis. And the who can benefit from this technology, both DJI and the AGREMO. First of all, the farmers who will use this tool to lower the amount of the chemicals that they are using, and also, to be more efficient in their production and make savings on the chemicals. With that together, they have the complete solution to do their regular field monitoring with the AI-based analysis. The service providers will have the option to offer new services for their customers. They can offer the spot spraying and use the less chemicals, and also they can add the additional services such as stand counts and plant health analysis to their portfolio. For DJI resellers, they can have a additional product or bundle to create to where they can have the hardware and the software and the whole package. And the input producers, we work a lot with the input producers, the chemical and seed companies who are either using spraying drones for their own tests, but also we have the designed tool specially for them for analyzing research trials and trait collections. So thank you all very much. And Nevena, please.
And now it's time for the second poll question. You have 30 seconds for that. And just remind all our listeners to feel free and drop a question in the Q&A session on the right-hand side. I see that you already have a lot of questions. So if we don't answer everything today, don't worry. We'll do it immediately after the webinar and send it via email to you. So I think we can go on Q&A session. So Luka, Nemanja, please. DJI Terra doesn't have recognized options, please. You can check and answer immediately.
Okay, yeah, I see the one question which is based on the pricing structure, which is my part of the job. Okay. So yeah, it is a license based. So it's not per acre, it's the license based. So for all other details, please contact us as on sales at AGREMO.
Okay, so if I can take another question and see, for the sprayer drone, what rate do you spray? I assume it's way less than conventional sprayers, and can you use all existing chemicals? So yes, what we used, and I will talk about the specific example that Luka mentioned. So the rate per hectare was 28 liters, where it was the same concentration as would be used in the regular let's say 150, 200 liter per hectare unit. So the concentration of the tank mix remains the same, but you're applying way less, just focused and more concentrated. And I am not aware that there are any restrictions as it comes to chemicals.
Maybe Nemanja could also answer to the next one. Do you have analysis or studies on fruits such as pineapples?
I am not sure about pineapple specifically, but we do do a lot of analysis in orchards, and especially recently we come up with a canopy sizing analysis, which allows you to not only count plants, but also measure the circumference of each canopy in your orchard.
Okay.
And while I'm answering one, I also saw one question that was interesting to me, so I would like to answer it as well. So does the ground sprayer need PWM nozzles for spot spraying, or do you operate the section control? We are completely agnostic from that part. If you have an unlocked license for variable spraying, whether you're using section by section or nozzle by nozzle, our maps will be supported. We have the adjustments of resolution, so you can set up the, let's say, pixel size to be either 3 by 3 or 10 by 10 or even 20 by 20 meters. So depending on the type of equipment that you have, you can adjust your maps to be more or less precise.
And there is one question for Wing. When the AGRAS T40 will be available in Europe? If yes, when?
That's a good question. It should be quite soon, but for the exact days, I honestly am not quite sure about the regional supply there. But according to what I know, it should be quite soon. And if you are interested in knowing more, what I could do, could type my email in the chat box, and please do send me an email, and I can follow up with the details.
Perfect. Nemanja, I think this will be the last one. How much time is needed to create prescription maps after drone multispectral image upload?
Yeah, of course. So first you would need to request the analysis, which I saw that somebody mentioned the size of the field. That is not the most important part. What is important is the area of the phenomena. So depending on the complexity of your map and depending on how much of the specific phenomena you have, that will depend on the turnaround time. But usually you can expect your results to be ready in 24 hours, after which creating a prescription map is just a matter of minutes. You just need to input the rates and select the zones and the units that you're going to use, and you're all set.
And I will just one last question for Wing. So do you recommend the M3M for survey mapping instead the M3E?
So actually for the RGB camera, the Mavic 3 Enterprise and the Mavic 3 Multispectral, they are the same from both hardware and software perspectives. They are exactly the same. But if you are thinking of doing agricultural mapping projects and environment mapping projects as well. For example, to monitor the growth of the crops and the launch of the crops, and also vegetation cover of forestry, for example, then the multispectral would give you more power in those scenarios. So if those are under your scope, then I would recommend multispectral version. But if you are thinking only doing land surveying and you don't need the multispectral cameras, then definitely go for the Mavic 3 Enterprise.
Thank you. So thank you, Wing. Thank you, Nemanja and Luca. Thank you all. Our belief is that precision ag technologies will find its place in all agricultural production systems in the near future. So just to remind you that you will receive an email containing a link to this broadcast. so that you can watch it again or share it with someone who might be interested. If you are interested in our end-to-end solution, you can schedule a demo and write an email on sales@agremo.com. That's all for today. I hope you enjoyed, and I hope that you got some answers. And thank you for attending. Stay safe and see you soon. Bye, everybody.
Can I add one last message?
Yes, of course,
before everyone leaves? So in the following weeks, DJI site will also follow with a technical training on how exactly to use the prescription map generated in AGREMO on the AGRAS drone to do spot spraying, or variable rate spraying and spreading as well. So that would be a very technical focused training webinar. Emails will be sending out to DJI distributors and also subscribed DJI users. So if you are interested and got curious about the solution after today's webinar, do pay attention, and we look forward to your participation in the following webinars.
Thank you, Wing. Thank you all. Bye-bye.
Bye-bye.